Welcome to next lecture of compiler design, and today we will discuss error detection and recovery. I am Dr. Parul Yadav, Assistant Professor at Department of Computer Science and Engineering in Institute of Engineering and Technology, Lucknow. So, here we will focus on what are the various compiler errors, how the errors are actually reported. So, reporting of errors, then what could be the possible sources of error. So, here we will discuss sources of error. Then we will discuss what are the lexical errors in compiler, syntactic errors and the semantic errors. So, first is the errors. So, we know that the compiler has the phases, 6 phases, and here we have two components, two important components of the compiler. One is the symbol table and second is the error handler or error handler here. So, each and every phase of the compiler is linked to this error handler routine. So, here we will write the source program, the input to the compiler, it will be written in high level language. So, this input will be given to the compiler and that input program may have errors, and these errors can be of various kinds. So, we will try to handle the error and we will try to recover from the errors also. So, this is a source program that we have, and later on it will be translated through the compiler. So, what the compiler, what is the expectation from the compiler? Expectations are it should direct attention as many errors as reasonably possible. Second, compiler acts as an effective communication device. If we are talking about error, then it should act as a effective communication device in between the machine and the user, and it should deliver the comments that the user can understand. If the program contains the error, then compiler will deliver the comments, and that comment should be in a manner or in a language that the user or the end user can understand with that what error has occurred in the program. Next, it should detect and recover from the errors. So, it is expected from the compiler that it should not only detect the error, rather it should recover from the error also. So, these are the major expectations from the compiler with respect to error if it occurs in any program. Now, next is what is unacceptable modes for the compiler. So, in unacceptable modes we can say it can produce a system crash. If it will not handle the error properly, then it may produce a system crash. Second, it may emit the invalid input. Third, it can quit on the first detected error. So, if we have written a lengthy program and there is error at particular point, then it can quit the program after detecting the first error only. Rather, it is expected that it should scan through the entire program even if it is having any error at the very beginning or at a particular stage in a program. So, this is about the basics of the compiler. Now, we will discuss how based on the errors we can classify the compiler. So, we can have here basically 3 categories of the compiler. First is a simple compiler. So, what the simple compiler will do in case of error handling, actually it may stop all activities other than lexical and syntax analysis after the detection of first error. So, as we detect the first error, it will stop all the activities, but it will continue the task of lexical analysis and syntactic analysis, while task of other phases of compiler can be resumed, can be stopped at that particular activity. So, this is known as simple compiler. Now, next category is complex compiler. So, complex compiler, it may attempt to repair the error and transform the erroneous input into the similar but legal input on which normal processing can be resumed. So, here actually it will try to repair from the error. So, wherever if we have the error, it will try to repair it. Next is other sophisticated compilers. So, the third category is here we only repaired, and here we will attempt to correct the erroneous input by making a guess to what the user indented. However, it is very difficult to know what the programmer is actually indented, what is the implication of the programmer, but here we will try to attempt to correct the erroneous input by making the guess. Now, there are reporting of errors. What could be the possible ways for reporting the errors? First, it could be the pinpoint the errors in terms of original source program. So, how we actually report the error? We can pinpoint the place where we have the error in the original source program. Next is the reporting of error, it should be tasteful and user understandable error messages should be given. So, it should give the message that a user can understand, the manner in the way the user can understand. For example, suppose we have a missing right parenthesis, suppose we have written this, or suppose a small like this, right, and there is no right parenthesis here. So, we can say that here we have missing right parenthesis, and it should mention what should be the line number also. So, it should be the manner, it should be tasteful for the user, rather than printing the message like this one OH117 mean the in some internal messages, it should print the message that are user friendly. Next is specific messages localizing the problem. Sometimes it may happen that some error has occurred due to not declaring a variable in some local procedure. So, it should give the proper specific message for that particular missing declaration, rather than simply writing missing declaration. It should give the message, suppose we have the variable that is not declared in procedure ABC. So, it should clearly should clearly give the message that procedure not declared in procedure, variable not declared in procedure ABC, rather simply printing missing declaration. Now, next is in case of redundancy. Suppose redundancy mean there is one variable that is not declared, but used at many places. So, we can the error handler will tackle this situation it will provide no redundancy. So, it mean the undeclared variables. If we have undeclared variables, then the message should be printed only once. So, suppose this variable var is not declared and it is used at many places in the program. So, the error handler may print the missing variable or undeclared variable at multiple times, but the error handler routine here what it will do? It will remove the redundancy, and for such cases it will print error message only once. We will see later how it will be taken care by the compiler, but here we are just seeing that it will provide no redundancy of messages. Now, next is the sources of error. So, there are actually 6 sources of error we can say. One is a designing error, algorithm error, coding error, transcription error, compilation error, or runtime error or other error. So, one source is designing error, mean we will write the program and we will take the design specification, but if we are having the design specification and they are inconsistent or faulty, so that may result in error. Second, algorithm error, mean we will have the problem statement, and for that problem statement we will write the algorithm, but if the algorithm used to meet the design may be inadequate or incorrect, mean algorithm itself is incorrect. So, this could be the possible source of error. Next, the coding error, mean we will have the error, then we translate the algorithm and we will use a particular language, programming language to make a program for the particular algorithm. So, while doing the coding, if we introduce the error in implementing the algorithm, like it could be the logical error or using the programming language constructs improperly. So, this could be the coding error, right? Suppose a user wants to write suppose if A is equal to B, right. And suppose here the user is intended to write actually comparison. So, it should be like this, and somehow by mistake the user has written like A, if A is equal to V. So, this will this is some type of coding error that the programmer has done over here, and sometimes the constructs of the programming language may not be used by the programmer properly. So, this could be the source of error. Now, next is a transcription error. This may occur due to the typos or key punching. If we are using the punch card and punch we are doing or we are typing, then some typos may also be done. It could be like some missing character. Suppose I want to write suppose while, and it is written like this, and I missed to write E over here, or suppose some thing like I want to write int and I, and in transcription error typos are there, and suppose after this I need to put semicolon, rather than putting semicolon somehow I placed here colon. So, like this. So, this is just the typos that can be the part of error also. Next is the compilation error. So, these errors are introduced by the compiler itself while doing the translation. This is also possible. However, a compiler designer will try enough not to have such type of error, even everyone tries. Now, next is runtime or other error. So, here exceeding a compiler or machine limit, like error declaration with too many dimensions or to fit in symbol table. Second, the runtime error, like array with too large size to be allocated to the space of runtime. So, this could be the runtime and other types of error. So, these are the sources of error due to which error may occur. Now, we will discuss briefly the common programming language. So, common programming errors. So, first is the lexical error, syntactic error. Here we will discuss lexical, syntactic, semantic and logical in brief. So, in lexical error, what type of error actually occurs? Like misspelling of identifiers, keywords or operators. For example, suppose a user or programmer wants to write a variable like eclipse size, and it is like this, but by mistake the user has written it like this. So, this is the misspelling of the identifier, wrongly written typed identifier we can say. Now, missing quote around the text indented as a string, we are declaring the string, but we miss the quotes. So, this could be the lexical error. Now, next is the syntactic errors with respect to grammar. This is with respect to string composition, this is with respect to the grammar, how the tokens are actually grouped, is the grouping of token is grammatically correct or not. So, in the syntactic error, like we know that every statement in suppose in C programming language should be ended by semicolon. So, suppose we misplaced semicolon, or suppose extra or missing braces like this. So, we are writing some line and suppose we put extra parenthesis or somehow we missed some parenthesis. So, this could be the part of syntactic error, mean the construct or the statement is not as per the syntax of the language. Now, next is another example for syntactic error could be like the appearance of case statement without an enclosing of switch statement. Now, however, the situation is usually allowed by the parser and caught later in the processing as compiler attempts to generate the code. So, this could be the another error where the construct is not as per the grammar of the language, programming language. Now, next is the semantic error. Semantic error mean the construct is not meaningfully correct. So, grouping of token is not meaningfully correct. So, here the semantic error mean it include the type mismatch between the operator or operands. Now, suppose we are writing A plus B and suppose A is of integer type, this is suppose of character or float, anything like that. So, here the grouping is not meaningful we can say, and this could be the type mismatch. And next another example of type mismatch, suppose we are talking about a function where we are using the formal parameters and then we are having the actual parameters, and there is type mismatch in between the actual parameters and the formal parameters. So, we can say this is the type of semantic error. Next, another example is the return the value in the Java method with return type void. We declare the void return type even if the program is returning some value. So, this could be the type of semantic error. Now, we will discuss some logical errors. So, anything from incorrect reasoning on the part of programmer. So, this is the logical error, we can have the program that is that does not have lexical error, or even it is syntactically and semantically correct as per it is satisfying the rules of the language, but the programmer has done some logical mistakes. So, this is the incorrect reasoning actually that is done by the compiler, and it use in C program of the assignment operator equal instead of comparison operator like this. So, as we already discussed that suppose a programmer wants to write this one, but by mistake he has written like this. So, this could be the logical error. So, they are the general or common programming errors in the program. Now, we will gradually proceed. Now, we will discuss more about the lexical phase errors. So, when it obtained actually, when it occurred actually, we already know in the lexical phase we find the tokens. We scan the input program from left to right and top to bottom, and we will try to find out meaningful sequence of characters, that is lexeme, and then we assign a token to it, and respective entries will be done in the symbol table as well. Now, here it discovers that no prefix of the remaining input fits the specification of any token class. In program we have written some identifier or the name, but that name is not matching to any of the specification of token. Just for example, suppose we have the variable name like ABC, and we can say yes, this is as per the specification for token class. This could be the identifier or correct identifier. Now, suppose next I am writing capital ABC, this is also correct. Now, next suppose I am writing 1 ABC, right. Now, suppose this is not as per the specification of particular language, then that compiler will give the lexical error for this particular construct. Now, what are the various problems in recovering from lexical phase error? So, we actually will detect the error and we also want to recover from the error. So, this is the lack of redundancy at lexical level of the language. Next, no one remedial action suits to all situations. So, what could be the general approach? We can skip erroneous characters until the lexical analyzer can find another token. So, we will keep on skipping the letters till we find the next token, and may likely cause the parser to see a deletion error. Next is the syntax error handling. So, here detecting an error as soon as possible, as we do in LL and LR methods that we are discuss in next lecture actually. So, here we will detect the error as soon as we are doing the parsing using the LL method or LR parsing methods. So, when the stream of tokens from the lexical analyzer cannot be parsed further according to the grammar for the language. So, we are doing it simultaneously. Now, a few semantic errors such as type mismatch can also be detected here efficiently. So, we are doing the parsing and the semantic analysis part. Now, there are various repairing transcripts error. Some hint has already been given at the beginning of the lecture. So, transcript mean user is writing and some error has been done due to typo, we can say. So, just what type of error may occur, like insertion of extra characters or tokens into the program. Now, deletion of the required character of the token. Next is replacement of the correct character or the token by the incorrect character of the token. And next type of transposition of two adjacent characters of the token. So, this could be the transcript errors that need to be repaired. Just see the examples for these errors that we discussed over here. Now, this could be the missing right parenthesis. For example, user wants to write this, programmer wants to write this, and here what we have, this is the deletion of required character or token, we can say. Now, here we have extraneous comma. So, like this we want to write INTA, but here we have insertion of extraneous character or token. Now, colon in the place of semicolon. Suppose I is equal to 2 and j is equal to j, this is semicolon, but here we want to write semicolon. So, this is the according to the replacement of the correct token or character with the invalid or incorrect character or token. Next is a misspelled keyword, like suppose here user wants to write while, and here we can say this is a transposition of 2 characters, right, or tokens we can say. So, here we have 2 characters that need to be transposed to get the correct one, or it could be done in the case when we are writing the identifier also. Now, extra blank, suppose user want to write this and this comment, and here the user has inserted extraneous character, that is a blank. So, these are the common syntactic error in the program due to the transcription of error. So, what is desirable here? To follow the minimum distance correction of syntactic errors. So, here we use a minimum Hamming distance method. So, what is this? This is the theoretical way of defining errors and their location, and here we define a collection of error transformations. And here the like suppose we have a program P and it has k errors. So, if the shortest sequence of error transformations that will map any valid program into P and it has length k, and using this we will try to calculate the minimum Hamming distance method, and this will be used for correcting the syntactic error. Now, see this program, here we have if A is equal to B, then actually we have missed the space. So, we forgot no space is there. Sum is equal to sum plus A, else sum is equal to sum minus A. So, programmer has written this construct, and if that such program will be translated, then initially this can be considered as identifier IFA, and then this will be treated as assignment operator, and this will assign the value B to this particular variable. But as soon as we get this, then we can decide that this is actually, here we will having the gap, right, otherwise there will be too many errors in the program. So, considering the minimum distance correction policy or a scheme, what we will prefer, we will insert extra space in between IF and A, and that will give us the correct code with k is equal to 1. However, no such we will not get any correct program or legal program with value of k less than or is equal to 1 in this particular case. So, we can say if we will put extra space in between if and A, if we will put a space in between if and A, we can get the valid code for k is equal to 1. So, this is based on minimum Hamming distance scheme. Now, next is the syntactic errors. So, here it is detected at the compile time or the run time. The examples are undeclared names and the type incompatibilities. Next is it required recovery from such errors and suppression of extraneous or duplicate error messages. So, it is expected over here as we discussed earlier. Now, how to recover from undeclared names? So, here what we will do, we will make entry for undeclared name in the symbol table with attributes when encountered first. So, suppose in the program we have undeclared variable, that is suppose where that we are having. So, in the symbol table we will create its entry. So, we are using the variable, but it is not declared, rather it is used at many places in the table. So, we will create its entry into the symbol table whenever it is first encountered in the program. Now, we will determine the attributes of that particular variable with respect to the context in which it is used. So, consider in the program we will find the context, and based on the context we will add the attributes in the symbol table for that undeclared variable. Now, we will set a flag into the symbol table to indicate that the entry made in response to semantic error rather than based on the declaration. So, this is actually based on the this is due to the error handler, not as the direct declaration by the programmer. So, it prints the error message only once for it and add new erroneous uses to it into the list. So, now next time whenever it encounters, then details will be added into the list, but no duplicacy of mean we will not print the error messages multiple time. Now, goal of the error handler. So, it reports the presence of error clearly and accurately. It recovers from each error quickly enough to detect subsequent errors. It adds minimum overhead to the processing of the correct program. It reports the place in the source program where the error is detected and print the offending line with the pointer to the position at which the error is detected. So, this is the goal of the error handler. Now, there are 4 schemes for error handling. They are panic mode, phrase mode, error and global correction. In panic mode, the parser discards input symbol one at a time until one of the designated set of synchronizing token is found. Next, the synchronizing token are usually delimiters such as semicolon or closing parenthesis or parenthesis, whose role in the source program is clear and unambiguous. Now, compiler designer must select the synchronization token appropriate for the source program. Now, next is it often skips a considerable amount of input without checking it for additional errors. Now, it has advantage of simplicity and it guaranteed not to go into the infinite loop. So, this is about the panic mode recovery. Now, next is the phrase level recovery. So, on discovering an error, perform local correction on the remaining input, that is, it may replace the prefix of the remaining input by some string that allows the parser to continue. So, and next a typical local correction is to replace the comma by a semicolon or delete extraneous semicolons or insert the missing semicolon. So, it based on local corrections scheme, and the choice of the local correction is left to the compiler designer. So, it is solely depend on the compiler designer. We must be careful to choose the replacements that do not lead to the infinite loop. So, this is the main thing, as it would be the case that, for example, if we always inserted something onto the input ahead of the current input symbol. So, used in the several error repairing compilers, it can correct any input string. Now, major drawback is the difficulty it has in coping with the situation in which the actual errors has occurred before the point of detection. Now, error protection and the global correction schemes, these schemes we will continue in the next class. So, thank you so much for the basics for listening the basics of the compiler, and here we discuss error handling and recovery, and error detection and recovery, and focus on panic mode and phrase level. Thank you so much.